Welcome folks to today's tutorial. Today we're looking at revising our work on circles. This will be the first of two tutorials. Today we're going to be looking at basically just basic naming parts of a circle, finding the basic circumference of a circle and finding the basic area of a circle. So we'll start by looking at labeling parts of a circle. What I'll get you to do, if you want to copy that down, you can pause it and then have a go at naming the different parts of the circle, as many as you can figure out, and then you can press play and I'll let you know what they're going to be. Okay, so for the first part, I've got the blue line, which is obviously the outside part of a circle, and the arrow. That is what we call the circumference. Okay, very important part, which is the distance all around the outside of a circle. Then the next important part is that line that goes from the center of a circle to the circumference. That is what we call the radius. The radius. The green line there that goes from one side to the other side, and that goes to the center of the circle as well. And it's kind of like two radiuses stuck together. That's what we call the diameter. And often we call it 2r because it's 2 times the radius. Another line that kind of looks like the diameter is this orange line. It goes from one side to the other side, but notice it doesn't go through the center of the circle. This is what we call a chord. And that chord actually creates, you can see, an area bound by that part of the circumference and the chord. That is what we call a minor segment. And I've got the little other purple arrow there. I haven't actually coloured in, but you can see where the cursor is going. That will be the other part, and that is what we call the major segment. Now the other area that kind of looks like a segment, often we get them mixed up, is this little piece of pie. You can see encased here by the part of a circumference and the two radiuses, and that is what we call, what do we call it? That's right, hopefully, a sector. A sector. You can also see that little part of the circumference that I drew in there. That is what we call an arc. Okay, so the sector is bound by an arc and two radiuses, or radii as we might call them. And the other line left here, hopefully you've seen, is the other red line, which is is a line which is outside of a circle. That touches the circle just on one point on the circumference, and that is what we call a tangent. A tangent to a circle. Okay, hopefully you got all those right. If you didn't, maybe you might, in an hour or so, come back and have another go at it. Okay, so that's the first bit. Second bit we want to look at is the circumference. The circumference of a circle. Okay, so coming on now to part 2, we're wanting to be able to calculate the circumference of a circle. Hopefully we recall that the rule is 2 pi r. 2 pi r. Remember that pi is a value that equals around about 3.14, but it goes on to be 1415926 ... And it goes on for a very, very long time. And obviously our calculator can't handle all the numbers there, so we just use actually the key pi, and it automatically has that number in there. Some of you are going, hold on, isn't the rule pi times the diameter? And absolutely, that is correct. They're both correct. As if we refer back to that last example, looking at naming parts of a circle, we said that the diameter was also known as 2 times the radius, because it's two radiuses stuck together. So obviously 2 times the radius is equal to the diameter, okay, which is where those two bits come from. So as long as you can remember one of those formulas, then you'll be okay. Okay, so how do we actually apply that rule to a question? Let's have a look at this question here, where we want to find the circumference. Okay, so we know that the rule for the circumference of a circle is c equals 2 pi r. I'll use this rule first, and then I'll quickly do the calculations for the second rule. So in this case, we've got 2 times pi, we did it on our calculator, times it by 9. Or we could type in 18 times pi, because 2 times 9 is 18. And then that will give us, to 2 decimal places, 56.55 centimeters. So, again, what we did there, we said 2 times 9, and we said times pi. That gives 18 pi, which is 56.55 centimeters. Remember, we're finding a distance or a length, so our answer's in centimeters there. How do you use the second rule? Okay, circumference equals pi times diameter. Well, it's exactly the same, because the diameter is twice the radius, okay, which is 18, so 18. So circumference equals pi times 18 equals 56.55 centimeters. Okay, just something to note, some questions will ask you to leave the answer in what we call exact form. Okay, exact form. All that means is that we don't want to have any decimal places, we don't want to be rounding, and the only way we can do that is actually if we give our answer in that form. Okay, just 18 times pi, but we simplify it just to be 18 pi. Because obviously we know if we've got an 18 and a pi next to it, that there's actually an invisible times there. And that's his exact form, okay, and that's all that we would be expected to sort of answer for that particular question. Okay. All right, so nice and easy for circumference. Again, as long as we remember those two formulas, that is ultra important. Obviously, without those two formulas, or either one of those formulas, we're going to struggle to answer these questions. Okay. So, area of a circle. Again, guys, unless we know this formula, we're going to struggle. Okay, we won't be able to find the answer. Really important. Area equals pi r squared, where r again is the radius. Some people tell me, oh, I can remember both the formulas for area and circumference, but I'm just not sure which is which. Sometimes I think this is the area is 2 pi r, and other times I'm just not sure. How do I know? And the best way that I look at it is that I know that with area, any area question, for this one example, it's centimeters, but any area question, we will answer it in units squared. In this case, it will be centimeters squared. So because I'm doing centimeters squared for area, this rule uses pi times radius squared. The two squares, it helps me just remember which one to use which time. Okay. All right, so let's have a look at this question. Area equals pi times radius squared. Well, let's have a look at the radius first of all. Very important to first note, have I been given the diameter or the radius? In this case, I've been given the diameter. So if we just halve that, we can say that the radius is 7.5 centimeters. So area equals pi times 7.5 centimeters. We can then simply type that into our calculator. Pi times 7.5 squared. You can do 7.5 times 7.5 if you would like. Either way, we come out to get 176.71 centimeters squared. Really important, that because it's area, and that is the 2 decimal places. If I just refer back to that last question, we spoke about exact form, where I didn't want to use pi as the value in the calculator. We just left it with pi. So how do I do it for this question? Well, we know it's pi times 7.5 squared. So actually what we have to do is just do 7.5 squared on my calculator. That comes out to be 56.25. And then pi. And that would be the exact form. Okay, nice and easy. One thing I will note, I've spoken about exact form, leaving your answer exact form, or leaving it as the actually calculated value of pi. Occasionally, they might say, use the fact that pi equals 3.14. If they tell you to use the fact that pi equals 3.14, instead of actually typing in pi on our calculator, we actually need to type in the 3.14. Okay, so in this case it'd be 3.14 times its 7.5 squared. So how might that differ? Okay, well, we type in 3.14, we times that by our radius squared, okay, so 7.5 squared, and we come up with the answer of 176.625 centimeters squared. Obviously rounded would be 0.63, okay, but you can notice already the difference. It's only a slight difference, okay, only a slight difference, but it's really important. Okay, so have they just asked me to find the area? In that case, if they just ask you to find the area, we always use a calculator for pi. But if they give you another value for pi, let's make sure that we use that. Okay, I hope this has been useful to you. Play as many times as you need to, but make sure that we consistently revise these sections. If you feel comfortable, you can move on to the next section, which will be the more challenging questions with circles.